Dear students, Demoivres Theorem chapter is going on. In the topic of Mathematics 2A textbook, Demoivres Theorem IPA is going on. Yesterday, in exercise 2A, we have completed Roman number 2, one sum. First sum we have completed, and the third also I said. Let us discuss about Roman number 2, second question. It is most IMP 7 mark sum. That only in second question, first part and second part only IMP, third part is not at all necessary. If cause of question is that if cos alpha plus cos beta plus cos gamma is equal to 0 is equal to sin alpha plus sin beta plus sin gamma. Show that first one cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos of alpha plus beta plus gamma. Second one sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 sin of alpha plus beta plus gamma, and this is for objective. This is the synopsis of objective. Third bit cos of alpha plus beta plus cos of beta plus gamma plus cos of gamma plus alpha equal to 0. This is the question. Let us see the solution. Given cos alpha plus cos beta plus cos gamma equal to 0, comma sin alpha plus sin beta plus sin gamma equal to 0. Multiply here for this one, for sin terminology, multiply by I both sides. That implies I sin alpha plus I sin beta plus I sin gamma equal to 0. Let it be second equation, and this cos alpha plus cos beta plus cos gamma equal to 0 be first equation. Now 1 plus 2, add first equation and second equation. In order I am writing cos alpha plus I sin alpha. Yesterday we discussed the sum. The answer is 3 by 2 sum, example sum. In the similar way, add this first term, second term, including I. So that is cos alpha plus I sin alpha. It is an order, and cos beta plus I sin beta. Write in the order of alpha, beta, gamma. Cos alpha plus I sin alpha plus cos beta plus I sin beta plus cos gamma plus I sin gamma is equal to 0 plus 0 is 0. Let here we can write let A is equal to cis alpha. So cos alpha plus sin alpha meaning cis alpha directly, and B is equal to cis beta, and C is equal to cis gamma. If A plus B plus C is equal to here A plus B plus C is equal to 0, we can conclude here cos alpha plus I sin alpha plus cos beta plus I sin beta plus cos gamma plus I sin gamma. A plus B plus C is equal to 0. So A plus B is equal to minus C you take and write here cubing on both sides. So you can write here A plus B whole cube is equal to minus C cube. The formula A plus B whole cube is equal to A cube plus B cube plus 3AB into A plus B is equal to minus C. That implies A cube plus B cube plus 3AB into, instead of A plus B you can write minus C is equal to minus C cube. That minus C cube taken this side, it becomes A cube plus B cube plus C cube. A cube plus B cube plus C cube is equal to 3ABC. Of course, we know this one very well. Without proof directly also you can write that this is the third equation. That implies substitute the value here cos alpha plus I sin alpha whole cube. Cos alpha plus I sin alpha whole cube plus cos beta plus I sin beta whole cube plus cos gamma plus I sin gamma whole cube. Cos gamma plus I sin gamma whole cube is equal to 3 into ABC. ABC you can write here cis alpha into cis beta into cis gamma. Cis alpha into cis beta into cis gamma. That implies, according to Demoivres theorem, you can write here cos 3 alpha plus I sin 3 alpha plus here cos 3 beta plus I sin 3 beta plus cos 3 gamma plus I sin 3 gamma is equal to, here 3 cis alpha cis beta cis gamma. The formula cis alpha into cis beta into cis gamma is equal to cis of alpha plus beta plus gamma. So write here 3 into cis of alpha plus beta plus gamma. That implies, next step we can write cos 3 alpha, take as a group real parts, cos 3 alpha plus cos 3 beta plus cos 3 gamma. Write this one as a group plus I taken common, and within brackets you can write here sin 3 alpha plus sin 3 beta plus sin 3 gamma. Here you expand this one as cis means cos plus I sin. So 3 into cos of alpha plus beta plus gamma plus I into 3 sin of alpha plus beta plus gamma. Now comparing real and imaginary parts both sides. Comparing real gamma imaginary parts. Comparing real comma imaginary parts both sides we get cos 3 alpha plus cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos of alpha plus beta plus gamma, because it is real part. Next you can write here by comparing imaginary part sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 sin of alpha plus beta plus gamma. 3 sin of alpha plus beta plus gamma. Here it is okay. Now consider for the third part of this problem. I am going to discuss with you the letter consider 1 by A plus 1 by B plus 1 by C. I am considering 1 by A plus 1 by B plus 1 by C. That meaning 1 by cis alpha. 1 by cis alpha plus 1 by cis beta plus 1 by cis gamma. 1 by cis alpha plus 1 by cis beta plus 1 by cis gamma. 1 by cis alpha gives cis of minus alpha, and 1 by cis beta gives cis of minus beta, and 1 by cis gamma meaning cis of minus gamma. you can write this one as cos alpha plus cos beta plus cos gamma minus of I taken common, that meaning cos alpha minus I sin alpha plus cos beta minus I sin beta plus cos gamma minus I sin gamma. Taking common like this, cos alpha plus cos beta plus cos gamma minus I into sin alpha plus sin beta plus sin gamma. Sin alpha plus sin beta plus sin gamma. Sin alpha plus sin beta plus sin gamma. Cos alpha plus cos beta plus cos gamma is equal to 0 here from first equation. And sin alpha plus sin beta plus sin gamma is equal to 0 here from second equation. Here, this one from second equation. That is from 1 and 2 you can write this is 0. From 1 comma 2 that is equal to 0 plus 0 that is equal to 0. So what is 0 here? Whatever we have taken 1 by a plus 1 by b plus 1 by c equal to 0. So here you can write 1 by a plus 1 by b plus 1 by c is equal to 0. That implies taken LCM ab plus bc plus ca whole by abc is equal to 0. ab plus bc plus ca is equal to 0. Now you can write ab plus bc plus ca is equal to 0 by taking cross multiplication. ab plus bc plus ca is equal to 0. What is ab? Cis alpha. Here I am writing. What is ab? Cis alpha. Cis alpha into cis beta. Plus what is bc? Cis beta into cis gamma. What is ca? Cis gamma into cis alpha. Here I am writing the AB value cis alpha dot cis beta. Cis alpha dot cis beta plus cis beta dot cis gamma plus cis gamma dot cis alpha equal to 0. You can write. Okay, next step I am writing. This is a cis of alpha plus beta plus this is cis of beta plus gamma plus this is cis of gamma plus alpha equal to 0. Cis of alpha plus beta you can write as cis alpha cos of alpha plus beta plus I sin of alpha plus beta plus cos of beta plus gamma plus I sin of beta plus gamma plus cos of gamma plus alpha plus I sin of gamma plus alpha is equal to 0 plus 0 into I. Like that you can write. I am writing like this. Cos of alpha plus beta plus cos of beta plus gamma plus cos of gamma plus alpha. Take a bracket here plus I taken common. Fully imaginary part you write. Sin of alpha plus beta plus sin of beta plus gamma plus sin of gamma plus alpha. That is equal to right here 0 plus I into 0. 0 plus I into 0. To get the answer, here we need to compare only real part. Even though imaginary part you compare, you will get the answer sin of alpha plus beta, sin of beta plus gamma plus sin of gamma plus alpha equal to 0. In object, these are all synopsis. Compare real part. Comparing real part to both sides, you can get cos of alpha plus beta plus cos of beta plus gamma plus cos of gamma plus alpha is equal to 0. That's all. If you compare this one also equal to 0, you can write, but this is only for objective. Whatever the two parts we have proved, cos of alpha plus beta plus gamma is equal to 3 cos alpha plus cos beta plus cos gamma equal to 3 cos of alpha plus beta plus gamma, and sin alpha plus sin beta plus sin gamma is equal to 3 sin of alpha plus beta plus gamma. Only two parts are important, most IMP for 7 marks in IPU. In mains, this is not at all IMP, simply remember as a formula. Wherever it is necessary, you can apply. Now fourth question. Exercise 2A, fourth question. In the chapter Demoivres Theorem, exercise 2A. Roman number 1, fourth question is there. If 1 plus x whole power n is equal to fourth question, two parts are there. If 1 plus x whole power n is equal to a naught plus a1x plus a2x square plus so on an x power n, then show that first one a naught minus a1 plus a naught minus a2 plus a4 minus a6 plus so on is equal to 2 power n by 2 cos n pi by 4. Second one a1 minus a3 plus a5 plus so on is equal to 2 power n by 2 into sin n pi by 4. Given 1 plus x whole power n is equal to a naught plus a1x plus a2x square plus a3x cube until a6 he is discussing. So until a6 I am writing. So a3x cube plus a4x power 4 plus a5x power 5 plus a6x power 6 plus so on. Of course, plus an x power n is there. Put this is first equation. Now put x is equal to I. In this equation, put x is equal to I. Right here, 1 plus I whole power n is equal to a naught plus a1 I plus a2 I square, a naught plus a1 I plus a2 I square plus so on until I power 6 I am writing. a3 I cube plus a4 I power 4 plus a5 I power 5 plus a6 I power 6 plus so on an I power n. This is second equation. Now put x is equal to minus I. Right here 1 minus I whole power n is equal to a naught plus a1i, a naught plus a1i plus this is minus a1i plus a2i square, this is I cube. Okay, better to take the values here, lateral consumption. This is not second equation, better to take the values. That is equal to, so 1 plus I whole power n, 1 plus I whole power n is equal to a naught plus a1i minus a2, because I square meaning minus 1, I cube meaning I square into I, so minus 1 into I, it is minus I, so this is minus a3i. I power 4 means I square whole square minus 1 whole square is 1, so simply a4, I power 4 into I, this is a5i. I power 6 means minus 1 because my I square whole cube plus so we don't know whether it is positive or negative, we cannot say, so simply leave it. I power n, right? This is second equation. Now put x is equal to minus I in 1, here also in 1. So 1 minus I whole power n is equal to a naught minus a1 I plus a2 into minus I whole square plus a3 into minus I whole cube plus a4 into minus I whole power 4 plus a5 into minus I whole power 5 plus a6 into minus I whole power 6 plus 1 plus an into minus I whole power n. Now let us expand 1 minus I whole power n is equal to this is a0 minus this is a1I minus I whole square or I square because minus 1 whole square is 1 minus I square is nothing but I square is equal to minus 1 so minus a2 you write here minus I whole cube minus 1 whole cube becomes minus 1 I whole cube becomes minus I so this is a plus a3I of course this is a plus a power 4 minus of minus 1 whole power 5 becomes here minus a5 into this is not 9 this is 5 a5 into minus I whole power 5 so minus I whole power 5 means I power 5 means only simply I because I power 4 is equal to 1 so minus means it becomes only minus right minus a5I a6 minus 1 power 6 becomes minus 1 I power 6 becomes I square whole power 3 so minus 1 whole power 3 is minus so it is minus a power 6 plus so on simply write leave it minus 1 whole power n to a power n I power n now this is third equation now you can write 2 plus 3 1 plus I whole power n plus 1 minus I whole power n is equal to simply add this one and this one a0 to a1I get cancelled minus 2a2 yeah we are getting 2 taken common minus a3 get cancelled this is plus a4 minus a6 yeah plus so on simply leave it that's all plus so on now you can understand that 2a0 into this a0 minus a2 plus a4 minus a6 plus so on is equal to here 1 plus I whole power n plus 1 minus I whole power n you can write in terms of like this root 2 into 1 by root 2 plus I by root 2 whole power n because for the complex number x plus I by you should multiply and divide with root of x plus y square it is nothing but modulus amplitude form or polar form which is r into cos theta plus I sin theta form so r into cos theta plus I sin theta model I am writing so it is root 2 into once again you can write here 1 by root 2 minus I by root 2 1 by root 2 minus I by root 2 whole power n that implies 2 into a0 minus a2 plus a4 minus a6 plus so on is equal to root 2 you can understand 2 power 1 by 2 so 2 power 1 by 2 whole power n into 2 power that you take common you can write here this is cos pi by 4 cos pi by 4 plus I sin pi by 4 whole power n plus of take common like this cos pi by 4 minus I sin pi by 4 cos pi by 4 minus I sin pi by 4 whole power n that implies 2 into a0 plus a0 minus 2 into a0 minus a2 plus a4 minus a6 plus so on is equal to 2 power n by 2 into this you can write as cos n pi by 4 according to Demoivres theorem cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. So cos sin n pi by 4 minus I sin n pi by 4 get cancelled. So here you can write 2 into a0 minus a2 plus a4 minus a6 plus so on is equal to 2 power n by 2 into that I sin n pi by 4 got cancelled, so we got 2 cos n pi by 4. Here this 2 and this 2 get cancelled, therefore we got the answer for comparing the real part here. a0 minus a2 plus a4 minus a6 plus so on is equal to 2 power n by 2 cos n pi by 4. 2 power n by 2 cos n pi by 4. Real part we got. Let us do now 2 minus 3. 2 plus 3 we have completed. Now 2 minus 3. Second equation minus third equation we can write as 1 plus I whole power n minus of 1 minus I whole power n is equal to here a0 minus a0 becomes 0. a1i minus of minus plus a1i. So 2a1i for everything I you can get 2 into, now you can understand a1 plus a3 plus a5, a1 plus a3 plus a5 plus so on. a1 plus a3 plus a5 plus so on. Here this one directly already we used here. So directly we can write here 2 power n by 2 because this is imaginary part. I sin n pi by 2. 2i sin n pi by 4. Directly I am writing this one 2i into a1 plus a3 plus a5 plus so on. This 2 get cancelled. I also get cancelled. Therefore a1 plus a3 plus a5 plus so on is equal to 2 power n pi by 2 sin n pi by 4. Here the conclusion is that you can understand that whenever we are adding the trigonometric values in the complex number or Demoivres theorem concept, we used to get real part. Whenever you are subtracting that complex number concept or Demoivres theorem, you will get imaginary. So plus meaning cos, minus meaning sin. This is a simple shortcut, students. You can try to understand. No need to do full this sum in this lengthy method in objective. In objective also such models are there. Directly you might have to see. Students, we have successfully completed exercise 2A. Now we are entering into exercise 2B concept. Some theory is there before going to discuss about exercise 2B and examples. Let us discuss the theory. This is IMP concept. Nth root of a complex number. Nth root of a complex number. This is the side head. if z is equal to x plus iy is any complex number, that is non-zero. So z not equal to 0. If it is 0, there is no nth root, everything is 0. If z is equal to x is the non-zero complex number, if z naught is its nth root, z naught is any other complex number. Nth root of complex number may be a complex number. Z naught is nth root of it. It can be represented as z power n is equal to z naught, or z is equal to nth root of z naught. That is z is equal to z naught power 1 by n. Z naught power 1 by n. That's all. So depends upon, so here z naught is nth root of unity. Z naught is called as nth root of a complex. Enough. Z naught is nth root of it is enough. Now let us write the Demoivres theorem for rational index. For rational index, if n is equal to p by q, where q is not equal to 0, p by q is rational, that is cos theta plus I sin theta whole power n is equal to cos theta plus I sin theta whole power p by q. This you can write as cos p theta plus I sin p theta whole power 1 by q. So it is nothing but, so cos theta plus I sin theta whole power n is nothing but a cubed root of this complex number. So therefore cos theta plus I sin theta whole power n is cubed root of cos p theta plus I sin p theta. Of course, this cos p theta plus I sin p theta is the Demoivres theorem for cos theta plus I sin theta whole power p. We are indicating with the letter cos theta plus I sin theta whole power n. So in the similar way, z power n is equal to, in the concept, z naught whole power 1 by n. So this is z naught. Cos p theta plus I sin theta, here p is there, so it is another value z naught, that is z. Z power n is equal to z. So we can write z is equal to cos n theta plus I sin n theta. We can take this one as cos p theta plus I sin p theta whole power 1 by q. This is nothing but the rational index. So here cos, that is you can write under cos n theta. Here only you write cos n theta plus I sin n theta. Cos n theta plus I sin n theta is cubed root of cos p theta plus I sin p theta. Now let us going to discuss about nth roots of unity. It is most IMP concept for objective until JEE advanced level. This is at most IMP concept. Cos nth roots of unity. nth roots of unity. Before going to discuss nth roots of unity, let us going to discuss formula. Formula I am discussing. If z is equal to x plus iy is a complex number, z is equal to x plus iy is a complex number, and r into cos theta plus I sin theta is its modulus amplitude form, its mod amp form or polar form, then nth root of complex number nth root of complex number z power 1 by n, that is equal to x plus iy whole power 1 by n is equal to, right, like this, r into cos theta plus I sin theta whole power 1 by n. This is the definition I am discussing with you. R into cos theta plus I sin theta whole power 1 by n can be defined as, so nth roots of complex number can be defined as r power 1 by n into cis of theta plus 2k pi, cis of theta plus 2k pi whole by n. This is made, remember, as a formula. This is the definition. R power 1 by n is a cis of theta plus 2k pi by n, where k is equal to 0, 1, 2, 3, so on n minus 1. If it is nth root, you should write k equal to 0. Students, try to understand. Here k starting with 0 ends with n minus 1. Not start with 1 and ends with n minus 1. You can understand this one. Here it is 1 by n. 0, 1, 2, 3, so on n minus 1. Until here you should write. While discussing an example, you are able to understand. 0, 1, 2, 3, so on until n minus 1. You need to calculate all values. If it is period, 0, 1, 2, 3, p, so on, p minus 1. What is it? The value of k. What is the k? This is the definition. R power 1 by n cis of theta plus 2k pi by n. Like that you should write. Now, you can understand once again, if z is equal to x plus I is a complex number, its modulus amplitude form is r into cos theta plus I sin theta. We need to calculate the nth root of unity as r into cos theta plus I sin theta. That's all. R into cos theta plus I sin theta whole power n, not n, whole power 1 by n. You can write r power 1 by n into not cis theta cos 1 by n theta plus I sin 1 by n theta. It is not right. Cos of theta by n plus, whenever this you face this cos theta by n plus I sin theta by n, you need to calculate this formula as theta plus 2k pi by n. So what is 2k pi? Rotations. So by for rotations, first rotation, second rotation, that it represents angle rotations. Theta plus 2k pi means if you put here a 0, simply you can understand theta plus 0 by n, anything n. Next, theta plus 0. Second rotation, if you put first rotation, 2 second rotation, plenty of rotations you can manage, you can rotate, but depends upon n only. Theta plus value is there, that is why n should less than, here whatever the k we are using should less than n, so n minus 1. Sir, why you are using 0? 0 is nothing but starting angle for trigonometry ratio. Now n put side it. Now this one, nth roots of unity. Nth roots of unity. Unity means 1. Unity is equal to 1. So nth root of 1, you can understand 1 power 1 by n. Hereafter, every value can be considered as cos theta plus I sin theta form. So, write like this. This is, I am writing 1 plus I into 0. 1 plus I into 0 whole power 1 by n. That is equal to cos 0 degrees plus I sin 0 degrees whole power 1 by n. That is equal to, use this formula, r power 1 by n, there is no r. So directly you can write cos 0 plus 2k pi by n plus, this is 6 I am writing directly. This is I have written directly, separate I am writing. Cos of 0 plus 2k pi by n plus I sin of 0 plus 2k pi by n. Where you should write here k is equal to, where k is equal to 0, 1, 2, 3, so on n minus 1. So 1 has this many nth roots. You can imagine this example we are going to discuss in that. Take 15625 or maybe its root 625. Not 15625 into something, that root 625. 625 root 25, 25 root 5, 5 root like that, plenty of roots are there. If you take any calculator, a number is having minimum 25 roots until get 1. Try to understand what I am saying. Example, to take 256. 256 having a root, it is 16. Take 16. 16 having a root is 4. Take 4. It is having a root 2. Take 2. It is having root 1.414. Maybe it is a real number. And for 1.414, you take calculator and simply press the root value. For 1.414, you make it 1.2. Next 1.1, like that. You will get a minimum 25 to 28 roots for every number. In the similar way, for exactly one number, a one, it is one unity. It is having how many square roots? Square roots means here nth root. How many roots are there? There is a chance to get 0, 1, 2, 3, so on, n minus 1. What is n? Maybe if you put 3, 2 roots. If you put 4, 3 roots. If you put 5, 4 roots, like that, n minus 1 roots are there. Of course, if you put 0, it is also a root. Because whenever you are putting 0, 1 is a root. 1 is a root of 1. Now we are discussing about imaginary, not real roots. Students, imaginary roots. So not only real roots, other than real roots, imaginary roots we are discussing. What is imaginary? Complex here. 1 plus I had. Sir, here 0, sir, we got, even though no problem, you will be get the values. Now I will prove it. Cos theta plus I sin theta. So if k is equal to 1, if k is equal to 1, that is 1, k is equal to 0 first. If k is equal to 0, this is simply this cos 0 is 1 and I sin 0 is 1. That implies 1. If k is equal to 1, you can write here this is cos of 2 pi by n plus I sin of 2 pi by n. That's all. If k is equal to 2, that is cos of 4 pi by n plus I sin of 4 pi by n, like that. If k is equal to 3, that implies cos of 6 pi by n plus I sin of 6 pi by n, so on. If k is equal to n minus 1, so on. If k is equal to n minus 1, that implies the value becomes cos, put here n minus 1 instead of k, 2 into n minus 1 pi by n plus I sin of 2 into n minus 1 pi by n. These are the values. Now we are going to discuss about the difference of roots. I mean difference of the values of nth roots of unity and its properties. Therefore, nth roots of unity. How many roots are nth roots of unity? Are first one we got 1 comma. You indicate with this cis 2 pi by n. 1 comma cis 2 pi by n comma cis 4 pi by n. 1 comma cis 2 pi by n, cis 4 pi by n. Next cis 6 pi by n. So on cis of 2 into n minus 1 into pi by n, like this. So what you are observing? What is the difference between the roots? How the roots are in the, what is the progression for the roots? 1 into cis 2 pi by n, how much? Cis 2 pi by n. Cis 2 pi by n into cis 2 pi by n. Students, you would understand, right? You would understand what I am asking. Cis 2 pi by n into cis 2 pi by n. Cis alpha into cis beta becomes cis of alpha plus beta. So cis 2 pi by n into cis 2 pi by n becomes cis 4 pi by n. Next cis 4 pi by n into cis 2 pi by n becomes cis 6 pi by n. Cis 6 pi by n into cis 2 pi by n becomes cis 8 pi by n. So what you are able to understand, what understood or not, I think you could understand the difference is cis 2 pi by n. I mean not difference. Here it is geometric progression. The common ratio for two consecutive terms is cis 2 pi by n. These are in, right here, these are in GP. These are in GP. So these means here nth roots of unity always in GP. Nth roots of unity always in GP with common ratio. Always in GP with common ratio is equal to cis 2 pi by n. With common ratio is equal to cis 2 pi by n. Now sum of nth roots of unity. Sum of, you can add all the sums. Sum of nth roots of unity. 1 plus cis 2 pi by n plus 1 plus cis 2 pi by n plus cis 4 pi by n plus so on cis of, you can understand this one, cis 2 pi by n whole square. Cis 2 pi by n whole square, like this. Cis 2 pi by n whole cube plus 1 cis 2 pi by n whole power 2 into n minus 1. 2 into n minus 1. No, it is simply as this. This is of the form. Remember this one. A plus AR plus AR square plus so on AR power n minus 1. For this one, yes, n is equal to summation of sum of nth roots of unity. I am discussing summation formula A into 1 minus r power n by 1 minus r. Here n minus 1 is there, you should get r power n. So you can get it out here, r less than 1. Sir, if it is r greater than 1, you know that a into r power n minus 1 by r minus 1, but here it is 1 minus r power by 1 minus r. Why did you write r less than 1? Here we are discussing nth roots of unity. Example, we are discussing roots of 16 absolutely for 2 like that. So every number is less than 16 only. Simply we are discussing about nth roots of unity. So every root depends upon 1 and every root is lesser than 1. Whenever I am going for the theory of a complex number or Demoivres theorem, the formula is cos theta plus I sin theta. Whenever there is no proper root in real number, then only we are discussing about imaginary. So imaginary numbers of nth roots of unity is always lesser than 1. Don't forget student, this is less than 1. So here yes, A means 1 into 1 minus R power n you can understand here. 6 2 pi by n 1 minus 1 into here. 6 2 pi by n. 6 2 pi by n whole power n whole by 1 minus R. So whole by 1 minus 6 2 pi by n. So apply the Demoivres theorem here. 6 2 pi by n whole power n. What it becomes 1 minus 6 of, directly you can write 2 pi n by n whole by 1 minus 6 2 pi by n. Here n and n get cancelled. 1 minus 6 2 pi. You can understand students, 1 minus cos 2 pi plus I sin 2 pi. 1 minus cos 2 pi minus I sin 2 pi whole by 1 minus 6 2 pi by n I am writing. What is the value of cos 2 pi? It is 1. What is the value of sin 2 pi? We know that always sin n pi is 0. So we can write here 1 minus 0 by denominator, simply the value we don't know, 1 minus 6 2 pi by n. What? 1 minus 1 becomes 0. So you need to remember that sum of nth roots. Sum of nth roots of unity is equal to 0. Very important. You take any roots, exam 3 roots you are taking, 0, 4 roots, some 0, 5 roots, some 0, 10 roots, some 0, anything 0. Now let us discuss about product of nth roots. Product we can do. Sum of nth roots we have discussed. Now let us going to discuss about product of nth roots of unity. Unity means 1. Product of nth roots of unity. Product means into, write like this, 1 into 6 2 pi by n into 6 4 pi by n into 6 6 pi by n into so on. 6 of 2 into n minus 1 into pi whole by n. Students, 6 alpha into 6 beta into 6 gamma so on gives 6 alpha plus beta plus gamma plus delta, like that for everything it is plus. Now write 2 pi plus 6. Better to take students 2 pi by n, we can take common. Better to take 2 pi by n common. So 6 of 2 pi by n you take it common. Now you can write here 1 plus, I don't understand, 6 alpha 6 beta 6 gamma everything plus 6 2 pi by n plus 4 pi by n plus 6 pi by n so on 2 into n minus 1 pi by n. 2 pi by n I have taken common. It becomes 1 plus 2 plus 3 plus so on until n minus 1. Right now 1 plus 2 plus 3 plus 4 plus so on until n minus 1. I think you remember the formula of summation of natural numbers. Summation of natural numbers formula n into n plus 1 by 2. But here we are having n minus 1 terms only. One term missed. So now you should write here n minus 1 into n by 2. Now n and get cancelled, 2 get cancelled. You write here this is the 6 of n minus 1 into pi. 6 of n minus 1 into pi. Now that one you can calculate here. 6 pi whole power n minus 1. 6 pi whole power n minus 1. What is the value of 6 pi, students? Cos pi plus I sin pi. Cos pi plus I sin pi whole power n minus 1. So what is the value of cos pi? It is minus 1. Sin pi is 0. So product of nth roots of unity is minus 1 whole power n minus 1. This is most IMP formula in objective. Until advanced level you should remember this formula. Product of nth roots of unity. Product of nth roots of unity is equal to minus 1 whole power n minus 1. So Okay students, we have discussed in this class regarding nth roots of unity. For these nth roots of unity, special name is there. I will say the special name in next class.